How much time do we got?
8 minutes.
8 minutes? Okay, we can start the 1D hydrogen chain, finally. That is a solid. Surfaces are harder than solids. So solids, there's way more experiments and things to explore solids than there are surfaces. Like surfaces are started being visualized maybe in like 90s-ish, 80s. Even now, we can only visualize like blobs on top of surfaces. There's all sorts of new spectroscopy and spectrometry that's happening to look at these systems, but it's new. The other thing is theoretically, we weren't really able to explore these systems until like the late 2000s because exchange correlation functionals weren't that great. Getting dispersion wasn't really good. And then it became good overnight, it seems. And computers got faster. That helped out a lot too. Okay, we're finally there. This is when you'll want to start reading this thing by Roald Hoffmann, How Chemistry and Physics Meet in the Solid State. I think it's a good read. Check it out. But yeah, exactly. Let's talk about the 1D hydrogen chain. It's a great example because it shows many things and we can walk through the process and it's relatively simple. Quotes. Okay, we're going to think of a completely fictitious system that we know will break down in ambient temperature and pressure, but we're going to consider this fictitious system. Yes. A spherical cow in a vacuum. Let's consider a chain of H atoms that we loop over on itself. What would the MO diagram for these systems look like? Sorry, squeaky shoes today. Okay, what we're going to do, we're going to make kind of an extended figure that's going to go all the way across. We're going to have a number of H atoms. We're going to look at two, I guess we could look at one. Do we want to look at one? Look at 1, 2, 3. I didn't give myself enough room. I'm going to erase this whole thing and start over. Okay. We're going to draw an MO diagram. We're going to have number of H atoms. Then we're going to have, I need to make this smaller, son of a gun. I've become old. I just said son of a gun. Yeah. Yeah. How much money do I get out of this deal? Yeah.
I want grandkids.
Okay, let's look at 1, 2, 3, 4, 5, 6, and we're going to do a big jump infinity.
If you only did 3 or 4 of them, you'd have enough.
Yeah. Infinities or?
Yeah, if you only had 3 or 4, then you'd have
Yeah, yeah. 2 is good enough for in psychology, right? Okay, they're geometry. So how are these things going to look? There's our 1H atom just sitting out in space. 2H atoms. Yep, really has no other choice. What about 3? Yep, Triforce. 4. Square. 5. I didn't want that to go on yet. Good luck finding it.
No, that's not good. Is that going to go 100%?
Oh, yeah. That and guess my age. I love that one.
Let's go. I'm going to get 1 bonus point.
6. And then infinite. What have you noticed with what we're doing with these rings? Yeah, it's gonna make a giant circle in the end. Whoop.
So is an infinite size shape a circle?
I refuse to answer that question.
Yeah,
Yeah, there we go. Ask someone who cares a lot about it. Yeah. 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 Ask someone who's got time for that. I gotta get there. Okay. 1s orbital electron here. What happens as soon as we throw 2 hydrogens near one another? Yep, we get a bonding combination, anti-bonding combination symbol for these things. Yep, sigma star. If we draw kind of how they look. Oops, no. No. Bonding combination, atomic orbitals are in phase. What about anti-bonding? Yep. We're going to draw it this way to neglect the overlap. We're not going to allow them to mix because it's just visually easy to see when you're, well, easier to see when you're talking about infinitely long things. 3, we toss in another hydrogen atom. These systems do exist, which is weird. What's it going to look like? Nope. 2.
Are we unlocking p orbitals?
We are not unlocking p orbitals yet. All in phase with one another? What about here? Well, there's one, you have an anti-bonding that way, and one where we introduce a node right down the center, so there's no contribution from that guy. 4. I don't want to fill the electrons right now. Because we're going to get to a point where I'm going to have to draw a lot of them. 4. All in phase. How should I draw these 2? Or how should I shade them?
Let's shade like top left and bottom right.
Top left. Can't do bottom right. That's actually this guy. Completely anti-bonding case. It's okay. So what could you... There we go. That way or that way. What I want you to do is think about these other ones. When we get to... Because how much time? What are we at right now? All right, we're past time. Dr. Hill's going to be sitting out there. All right, that's all we got for now. Are there any questions?
How are the 2 and 4 not related by symmetry?
I'm sorry, can you, these 2?
Yes.
They are related by symmetry. And what ends up happening is you get a Peierls or a Jahn-Teller distortion to make them change.
Okay, I was going to say, because if they're the same by symmetry, then why wouldn't you just set 1 at their depth
Yep.
level, in which case the MO picture breaks?
Yep.
Okay.
That's that will happen, but we're going to touch that soon because something similar will happen down there. Okay. Other questions? All right.